The weather here is very unique in that we have all these different types of precipitation occurring in the same spot. And the underlying factor behind all of it is rain, rain, rain. It's one storm system after another comes in from the coast, and the rainfall just piles up.
And really what we're looking at here are these big mid-latitude frontal systems that make landfall onto the Olympic Peninsula, and how these systems kind of go from the ocean onto the land and then hit the mountains and start really growing vertically, and where some really intense convection and rainfall can occur.
So ground validation basically helps us understand how well the satellite is seeing precipitation.
So what we're trying to do with GPM is kind of build a three-dimensional view of precipitating clouds. And so in order to do that, we need measurements that are directly on the ground, and then we need measurements of the cloud, and then measurements kind of looking from different perspectives of the cloud.
Well, NASA will be providing two aircraft, the DC-8, which will be flying about mid-levels, 39,000 feet or so, and then the ER-2 aircraft, which flies much higher above the clouds. On the ground, the main assets are the NASA polarimetric radar, is where we are now, along with the D3R radar, which is a dual frequency, dual polarization radar that has the same frequencies as a GPM satellite. Well, we're quite remote, which is fine, but the hardest part actually for my group was to acquire land on the Quinault Indian Nation territory. There was we needed to make sure we were doing the right thing environmentally, get all the right permits. We worked very closely with the Quinault Indian Nation. They were wonderful. And then once we got all the regular permits, we had to then kind of cap the top of a mountain to support our radar, which requires about 1,500 pounds per square foot for it to be set on stably.
Some of my colleagues who work, actually had to hike in and put instruments in or go maintain instruments, 14-mile journeys into the woods, basically. It's really neat to get to work with, in such a unique environment like that, where you can, you're actually putting these instruments in places where there's never been measurements like that before.
We have sites all the way on the coast. They're going to see just probably 6 inches of rain for the season. We're going to have some sites that are going to be up the mountains that are going to see a couple of feet of rain for this season. And we also have instruments at around 5,000 feet. They're going to see probably a few feet of snow. So we're going to see quite a breadth of precipitation for this project.